Hello everyone of class 8 standard. Today we'll start the new chapter sound. Okay. This is chapter number 7 maybe in your exercise book you will get. So here today when we'll just talk about the sound. So first thing is coming in our mind that sound is a one form of energy. As we all know that light is a one form of energy, heat is a one form of energy. So sound is also a one form of energy. So all the properties of sound, that means the conservation rule of energy, that means one form to the other form, these all things are actually related to this one. Okay, this sound. So actually when the sound will just propagate in class 7, maybe you have learned these all things, that it always need a material medium to propagate. As we know that one, in case of the light wave or the light energy, that it doesn't need any type of medium to propagate through in a particular line. You don't There will be no medium. If there will be no medium, then also light can move from one place to other place. But in case of sound, definitely when a sound wave, it is actually a one type of wave, you can tell. Suppose if you draw this type of thing, then all the characteristics of wave is are present. That means what, if you know, we all know that, just I'm telling you the basic things first, then I will start uh, few more things here. If you consider these are the points, okay, a b c, 3 points. Suppose if you write here, then definitely few things you can notice. That is this part, okay. One is upward directional, that is one peak is here at the above the this axis, and one is just below the axis. In this way a wave will propagate. You all know that one. What is that one? This particular part is actually known as the crest, and this is the throat. So in this way a wave will propagate. This is the sound energy. How it will propagate? Suppose you are talking about the gaseous medium, then when the sound energy is propagating, then definitely there will be two part, where all the molecules of gas are just compressed in nature. They will be compressed, okay. And another portion you will get where these molecules are actually separated from each other in this way. So this part we all know that one, this is the compression part, and this one is the rarefaction part, okay. So these are the two things. Compression part means what? There the energy will be more, and higher energy, and this one is having higher energy, and this one is having the lower energy. So now what will happen when sound will propagate in this way? The vibration of the molecule, oscillation of the molecules will be starting here, and the energy will be transferred to one molecule to one system, compression to the rarefaction. Then when the compression, this portion energy will be just transferred to the rarefaction part, this area, then this part will be free to move, free from each other. So rarefaction will come here, and here the compression will come. Again, when the energy will be transferred, then this portion will be compressed, and the next portion will be rarefacted. So in this way the sound wave will move. These all things we know. Next thing is that how can you prove that sound needs a material medium to propagate? So we all know that one. Suppose you consider a jar system, bell jar system. Suppose if you talk about, that means suppose one bell is here, okay. Inside this one jar is here. Now if the this portion air is present, the gas is present, so bell, if the bell will be pressed, then definitely we can hear the sound. If all the air will be just coming out, or all the air will be evacuated from here, if you make a evacuated chamber here, then what you will get? When the bell will be pressed, then no sound will come. So from here we can easily conclude that what type of thing, that when there will be air, only that time we can hear the sound. That means sound can pass through the air medium only. When air will be not there, then definitely it will not pass. Three mediums are also there. We all know that the three known mediums: solid, liquid, and gases. So speed of sound is increasing in this way. Actually the speed of sound is more here in solid, then liquid, then gases, okay. So in this way these are the basic terms. Next thing is that while you are talking about the sound, then in your syllabus, that frequency and pitch, these two terms are actually present. So frequency and pitch, while you are talking about, Then before discussing this one, you have to know that two types of sound, two types of actually frequency related waves are there, sound are there. One is called the shrill and second one is grave. Okay, suppose you are talking about the shrill and the grave, these two types of thing. How can you actually just distinguish, differentiate these two terms? When the, suppose you are talking about few voices, I am just talking about the voice of a woman or a bird, okay, or in this case voice of a man, okay, or dog, suppose voice of dog. So in these two cases, what are actually the differences? The difference is that the shrillness. That means actually if you consider this one, the if the high pitch, these all are the high pitch sound, okay, high pitch sound. That means, or you can also tell that these are the high note sound, or you can also tell that these all are the high frequency sound also, high frequency sound also, okay. So these all are actually there, so you can distinguish, you can differentiate that women voice or the voice of the bird while they are singing. So this type of relation will come, okay. Frequency means what? That the number of waves passing through in a particular second, in 1 second, the number of waves. So that is actually the calculation of frequency. Now this particular pitch, while you are talking about, this is the shrillness of sound, and this one is a subjective matter, okay, and this one is a objective matter, that means frequency. Suppose you are talking about, most of the time if you just consider these all things, that suppose a frequency is written in this way, that 220 hertz, hertz is the unit of frequency, you all know that one. But if sometime it is written that a 220 hertz, okay, what for this a is standing? A is standing because of this pitch only, okay. This is not for the frequency, frequency is this one, okay. The proper measurement is there, which is having a proper measurement, you can tell. So that will be a frequency, and this one is actually the high pitch or pitch. That means how frequent a wave can pass through a medium, that will be calculated by the frequency. Listen carefully, that how frequently a wave can pass per second, that will be calculated by the frequency of sound. And how high or how low volume sound is coming to our ears, that will be calculated by the pitch. So that is related to these two things. If high frequency is there, definitely high pitch sound will come. If low frequency is there, then definitely low pitch sound is coming. So these are actually the basic difference between the pitch and the frequency. In case of this one, low frequency, just opposite of this one. That means low pitch will be there, low note will be there, and low frequency will be there. So these are actually the difference, or the definition, you can also tell that one. Number of waves divided by second, if you talk about, then that means actually the frequency. How the frequency is related to the wavelength of sound. Suppose I am talking about one wave, if I am just drawing here, that sound wave, suppose you are talking about, then so suppose you are drawing this type of thing. One wave is like this, okay. This is the wave number 1, and one wave you are just drawing like this, okay. What are the difference between these two? Suppose someone is asking the question, then definitely if you just measure this height for any cases in the upper side or the downward side, and if you consider this height, these all heights are definitely same. So this height is more, this height is less, okay. So if the question will be asked that where the frequency of sound is more, for which wave, this one or that one, that will be depending on the wavelength of the these waves. If the wavelength is more, then frequency will be less. That means frequency and wavelength are inversely proportional to each other, okay. So if wavelength is more there, so definitely frequency will be less. If wavelength is less there, then frequency will be more there, okay. So in this case, you can see that which one is having more wavelength, that is the class 7 standard physics, so I am not talking about this one. You can easily see from here that which is having more wavelength and which is having less wavelength. So that wave which is having more wavelength having less frequency, which is having less wavelength having more frequency. So these are the thing. In the next video I will talk about the instrument, different types of instruments. So thanks for today.